Alright, let's take a look at question number 2 on how to integrate using U substitution. So let's say you want to find the integral of dx over cosine square 2x. Okay, we're going to do this using the U substitution method. Now let's start off by rewriting what the formula is. Hopefully you remember. Let's just refresh our memories again. The formula for the U substitution method is the integral of f of g of x times g prime of x dx equals what? The integral of f of u du, the reversal of the U substitution, the chain rule differentiation method. Okay, this happens where u is the inner function g of x. Alright, so we're going to apply that here. So first thing we're going to do, as we did in question number 1, is we're going to rewrite this in a way where it's easy for us to identify what the inner and f of g of x are. Okay, the inner function and f of g of x. So let's go ahead and separate it. We want to write down the composite function, which is clearly 1 over cosine square 2x times the other function, which is just dx. Okay? Now, can you see what the inner function is here? Well, 1 over cosine square x is not an easily recognizable antiderivative or derivative. So what we're going to do here is, how about we write this in a format that's consistent with a known derivative? Remember your identities. Remember what 1 over cosine theta is? So 1 over cosine theta is what? Is a reciprocal identity. 1 over cosine theta is equal to secant theta. So that follows that 1 over cosine square theta is secant square theta. Okay, so using our reciprocal identities, we can rewrite this as rewrite this integral as the integral of secant square 2x dx. Now that looks much better. Okay, we know that secant square is a known derivative, so we can easily now identify what our inner function is. Our inner function here is going to be u. Okay, so we say u is 2x. Then what is du going to be? We differentiate both sides with respect to x. So we have du dx is equal to 2. Multiply both sides by dx. You have du is equal to 2 dx. Alright, so now do we have a perfect match for our substitution? Let's take a look at what we have here. We have du is equal to 2 dx, and over here we have dx. Do we have a match? The answer is no. We have a mismatch. Okay, why? Well, we have 2 dx here, and this is just dx by itself. So we need to have an identical match on the right side of our equation in order to be able to carry out the substitution. So in order to rectify the difference, what we're going to do is just simply divide both sides by 2, since we cannot have anything attached to dx in order for it to match this, the lefts to match this component perfectly. Alright, so when we divide both sides by 2, we have du over 2. Let's change colors. We have du over 2 is equal to what? Du over 2 is equal to dx. Bullseye. That's exactly what we want, because if you notice, now we have a perfect match. Now we can call this component right here du over 2. This is a very, very important step. You must know what u and the du or its multiple is before you carry out your substitution to avoid making errors. Okay? Now, what are we going to do? We're now going to carry out the substitution step. Okay? Substitution. Now, substitution step is as follows. We're going to have, what are we going to have? We're going to rewrite the integral as the integral of secant square, not 2x, but secant square u, and then replace dx with du over 2. Okay? Now let's factor out the 1/2 multiple there. So factor out 1/2, so we have 1/2 times the integral of secant square u du. Alright? Whenever possible, factor out multiples or coefficients or negative signs from your integrand because it simplifies the process considerably. Alright, so remember what the antiderivative of secant square theta is, right? If you integrate secant square theta, you end up with tan, because we know that the derivative of tan theta is secant square theta. Let's just write that down just as a refresher. If you differentiate tan, you get secant square theta. Okay, so when you integrate, you have tan theta plus c. So let's use that reversal of the differentiation rule here to integrate, and we're going to have 1/2 of, instead of secant square theta, the antiderivative is tan u. Remember, after you integrate, the integral symbol, this esh symbol, and the du go away together. Okay, and don't forget your plus c because this is an indefinite integral. Are we done? The answer is no. Whenever you substitute and integrate, you have to carry out your resub step. You have to resubstitute what you substituted out to enable your integration. So our substitution was u equals 2x. Now we are going to have to resub. What does that look like? The original problem, the answer that we got was 1/2 tan u plus c. Now we're going to resub. We're going to take our u and replace it with the original substitution we carried out, which is now 1/2 tan. Instead of u, we have 2x plus c. Ladies and gentlemen, this is the final answer to question number 2 on how to integrate using the u substitution method. Alright, we'd like to get your opinion on a question. On a scale from 1 to 10, how do you like your differentiation rules for trigonometric functions? On a scale from 1 to 10, how do you like your differentiation rules for your trigonometric functions? Sine, cosine, tangent, secant, cosecant, cotangent. Give us your response in the comment section below and tell us why you selected that answer.